if I want to make a higher order decoder and we have a stock of low order decoder, like if I want to make a 4 to 8, 3 to 8, 4 to 16 decoder or 3 to 8 decoder, and we have the stock of only 2 to 4 decoder, then how we can design this? What is the process to design a higher order decoder with the help of low order decoder? Okay, so this kind of procedure we call it the cascading of decoders. Okay, and let us try to see how we can utilize the cascading approach to make a bigger decoder circuit. So before I try to start designing, let us try to see what are the procedure to cascade the decoders so that we can get the higher order decoders. Okay, so see, the first step is, let us assume the m is the number of output that is required in the final decoder. So what does it mean? It means that, let us assume I want to design 4 to 16 decoder. What does it mean? 4 to 16 decoder means I have a 4 input, and based on those inputs I can decide, I can have a 16 number of outputs. Okay, so this is the first requirement that we should know. Second requirement is the number of outputs in existing decoder, like how many numbers of output we have with whatever by which we want to implement the higher order decoder circuit. So here n is the number of output, let us assume. Okay, so to calculate the number of stages, this formula need to be considered. Like in the first stage, we need n1 number of decoders. So the number of decoders in the first stage will be m divided by n. Again, please note that we need this m and n are always the order of 2 to the power n or 2 to the power x. Okay, this is always the order of 2 to the power x, where this x is equal to 1, 2, 3, and so on. Okay, so always this m and n are the function, like it should be like this one, order of 2 to the power n or 2 to the power x. Okay, so the number of decoder requirement in the first stage will be the n1. Now I need to check how many decoders are needed. Then if n1 is greater than or is equal to n, okay, whatever the n we have, if n1 is greater than or equal to 1, then I need to go for the second stage as well. So we cannot complete our designing in the single stage. We need to go for the second stage as well. Okay, so to calculate the number of decoders in the second stage, I need to calculate this formula, like n2 is equal to n1 divided by n, and this n1 is that we have already received from this one. Okay, so the number of decoders required in the second stage will be n1 divided by n, and then this the process will be continued until we cannot this condition is not satisfied. And if this condition is not satisfied, then we need to control it with the help of logic gates. So this is the procedure that we have to follow to cascade the decoders. So let us try to design something. Okay, first example is simplest example. Let us try to see, construct 3 to 8 line decoder with 2 to 4 line decoder. So if we see here, this 8 is nothing but this is the m, means the number of output we want to design, like number of output of the decoder that we want to design. And this 4 is nothing but this is the n, means the number of output what existing decoders we have. Okay, so I need to calculate n1 with this one. Okay, so what will be the n1? N1 is nothing but this is m divided by n, and if you see m is here 8 divided by 4, that is equal to 2. Okay, so what it means, 2 number of decoders are required in the first stage. Okay, 2 decoders are required. Okay. Now let us try to see, and this is nothing but n1, and this n1 is greater than or is equal to n. No, it is not true. Okay, if it is not true, then I have to control them with the help of logic gates. Okay, so this condition is not true, so I need to use some logical gates. So let us try to see how we can do that. So as of now, we got one information, like the number of decoders required in the stage number 1 is the 2. Okay, now I will fill this this table later on. Let us try to see what are the decoder requirements. Okay, so I just told you, as of now we need two decoders, and if we clearly see the decoder input and output combinations, so the output and input combination should be something like, if I have a 3 input decoder, if I want to construct 3 to 8 decoders, so the total input combination will be 0 0 0 0 to 1 1 1. So these are the input combination for the final decoder circuit. Okay, and we have only 2 to 4 decoder. Okay, and 2 to 4 decoder means what? I have 2 inputs and the total possibilities are 4 only, from 0 0 to 1 1. Okay, but if we can recall one more thing, in decoder we have an enable line that can decide whether I have to activate that decoder or not. Okay, so the decoder looks like this one. So yeah, so before that I just wanted to tell you, like, suppose I have an enable signal, okay, and I have a 2 inputs and 4 outputs for 2 to 4 decoder. So whatever the input combination I will get here, accordingly that output will be selected. Okay, if it's 0 0, then first will be selected, 0 1, then second will be selected, and so on. But even though there are some changes in the input, but if this E is equal to not 0, because this is the active low, so if E is equal to not 0, even though there is some changes over here, this decoder will not give any of the output, it will give a 0 output. Okay, so as we can see, this enable signal can also act as a one of the control signal that can decide whether I have to use this decoder or not. Okay, so what we will do, so the input, whatever we have 2, and we need 3 inputs. So these are the 2 inputs that we can utilize, and the third enable signal can also act as one of the control signal which can decide the number of outputs. How it will be decided? Let us try to see. Okay, so because if I have a 3 number of inputs, so the total bit lines or the total input lines requirements are 3. Okay, because I need 3 input and 8 outputs. Okay, so let us consider I have a 3 outputs, 3 inputs, B2, B1 and B0. Okay, B2, B1 and B0, these 3 are the inputs, and we know that any of the 2 input can be utilized to control the 2 cross 4 decoder. How it can be controlled? Let us try to see. Let us assume I have a 2 cross 4 decoder. Okay, and if I have a 2 cross 4 decoder means what? The 2 inputs that I'm controlling with the help of B1 and B0. So B1 and B0 input combination, like if it is 0 0, then this will 0 and 0 I will get, and the first output will be selected, and this output is also will be selected based on the enable signal. If I have a 0 1, okay, instead of I have a 0 1, then these 2 outputs will be selected, this one and this one. But what is our requirement? Our requirement is to select only one of the output, not the 2 outputs, because I am getting 2 outputs from both the decoders, one output on each of the decoder. So to overcome that problem, this B2 can be utilized. How this B2 can be utilized? If I can control like B2 directly, so if B2 is equal to 0, so if I have connected this B2 directly to the first decoder, then if B2 is equal to 0, this first decoder will be selected, and if B2 is equal to 1, then the second decoder will be selected. Yeah, so what will happen if I have a control something like this? Okay, so if I have connected B2 to the enable, B1 and B0 to the 2 of inputs, so the first output could be D0. Okay, so let us try to make the truth table. If B2 is equal to 0, okay, and B1 is equal to 0 and B0 is equal to 0, so I will get output D1. Sorry, D0. I will get D0 as an output. Okay, so D0 will be the output in this case. Okay, similarly, if I have a B2 is equal to 0 and B1 is equal to 0 and 1, then I will get this D1 output. Okay, so this is a very important point. And similarly, 0 0 0 1 0. Okay, in the 0 1 0, D2 will be the output, and so on, D4. So 0 1 1, that will give you the D3 as output. Now, because we need 8 outputs and 4 outputs we have finished from the first decoder, now I need to enable the second decoder. So to enable the second decoder, what we can do, we can simply make a complement. Okay, so once this B2 becomes 1, okay, this B2 becomes 1, I will get 0 over here, 1 over here. That will deactivate the first decoder, but it will activate the second decoder. Okay, so the B2 is equal to 1 will deactivate the first decoder, and that will activate the second decoder. And if it is like that, then what is the combination of B1 and B0? That will be like this output will be taken out, and that depends on the B2. Okay, so so if I have a 1 1 1 1 at the B2 and 0 0, for this case I will get D4. Okay, 0 1 I will get D5, and for 1 0 I will get D6, and for 1 1 I will get D7. Okay, so if you see here, in the first 4 set, the decoder 1 will be enabled, and in the second last 4 set, decoder 2 will be enabled. Okay, so this is all about how we can design a bigger circuit with the help of smaller circuits. Okay, is any doubt? If you have any doubt anywhere, you can ask the questions, otherwise we can move ahead. Okay, and this is what the 3x8 decoder we can make. So here we have a 3 inputs, and here we have a 8 output. Okay, so 3x8 decoder can be made. Yes.
So when we are enabling the decoder 2
Yes.
for B1 B0 0 0, why we are getting D4 instead of D0? Because we are giving the same in.
No. See, internally it is D0 means the first output. Okay, and we can consider at a D4 for if I'm considering it the bigger one. So that is why I'm saying it becomes a D4 if I'm making the 3x8 decoder. Yeah, internally it is nothing but D0, D1, D2, and D4 based on these inputs. Okay, but from outside I'm considering, yeah, so this is D0, D1, D2, D3 if I'm considering 2 to 4 decoder. But if I'm making 3 to 8 decoder, so the D0 of the second decoder will become the D4, D1 of the second decoder will become D5, D2 of the second decoder will be D6, and D3 of the second decoder will become D7. Okay, so this is how we can control it. So internally there's just D0, D1, D2, D3 only if I'm considering 2x4 decoder. But if I'm making the 3x8 decoder, in that case I can consider, because see, I just wanted to see, like, if you will make the truth table, then based on these inputs like B2, B1, and B0, you will get activated like this one, and you have to follow the sequence. It's not like you will get again the same kind of thing. Okay, you got the point? So I need to see this black box. Okay, so black box will treat as a 3 to 8 decoder. Okay, and accordingly we can decide the numbers. Okay, any other doubts? Okay, fine. So this is how we can construct. Let us try to take some more example. Let us try to construct 4 to 16 line decoder with 2 to 4 line decoder. Can anyone tell me how many decoders we need for this purpose? How many decoders we need for this purpose?
4.
4. Okay, 4 in stage number 1, right? And try to check for how many requirements will be there in the stage 2.
It's total 6.
Total 6. Okay. Any other? How you are saying 6?
So in stage 2, 2 more are required to
Okay.
and the 4 in front one. the output side. Two are connected in the input side.
Okay, let us try to apply formula. So Jayant has given some response. Let me check. Okay, how many decoders we need? See here, this 16 means this is the M. Okay, this 4, this is the N. So let us try to calculate N1. So N1 is nothing but this is, yeah, so let me write it here. N1 is equal to M divided by N, and that we are getting 4. Okay, so 4, this is the first stage decoders. Then because this N1 is greater than or is equal to N, yeah, this condition is true. So this condition is true means what? N1 is 4 here. So 4 divided by 4, that I will get 1, and this is the N2. So N2 will be 1. And now you need to check N2 is not satisfying this condition. So further decoder will not be required. Okay. So the total number of decoder will be N1 by N. That will give you the 1. Total decoder requirement will be 5 only. Okay. So Jayant said absolutely correct answer. He just given. So total number of requirement is 5. Let us see how we can control it. Okay. So I just told you 4 decoders are required in the first stage. Okay. So see here. This is the first decoder, 2x4 decoder. This is the second decoder. This is the third decoder and the fourth decoder. And I'm giving numbering something like this from D0 to D3, then D4 to D7. D8 to D11 and D12 to D15, and the reason is same what I just explained in the previous figure. Okay. Now, once we are getting these things, we have a control signal at the input side like B0 and the B1, B0, B1 in all. So if 0, 0 will be there in all the decoders, so D0, D4, D8 and D12 will be selected. Okay, if the 0, 0 is the combination. But what is our requirement? Our requirement is instead of 4 outputs, I need only 1 output should be high. Okay, and now this enable play a major role here. If somehow we can control this enable, and accordingly if I can get the output, then that will solve your purpose. So for that thing, yeah, so B1 and B0 is the common, and this is what B1 and B0 that we have already given, and we have connected to all the decoders. Now, this control signal, like this enable signal, need to be controlled with the help of decoder. And we know that 2 to 4 decoder has 4 outputs, and that the output of these 2 to 4 decoder will connect to all the enables. Okay, and that will activate respective decoder circuits. Okay, so see here, if B3 and B2 is equal to 0, 0, E1 will become 1 and rest 1 will become 0, 0. And if this is 0, 1, 1, 0, so accordingly E0, E1, E2 and E3 will be selected. And if we are connecting this E0, E1, E2, E3 to the respective enable signal from 1, 2, 3, 4 decoders, so it will be like this. Yeah, so here B3 and B2 are the 2 more inputs, and in total we are getting the 4 number of input bits, B0, B1, B2 and B3 here. So this is what the input we are getting, and this is what we are getting the outputs. But how to control this one? So E0 will be connected to the first decoder enable. Okay, E1 will be connected to the second decoder, E2 will be connected to the third decoder, and E4 will be connected to the fourth decoder. Okay, so this is how they will enable, and accordingly the respective output we can get it. Okay, so this is how simply we can decide. So this is what the 4 to 16 decoder can be made with the help of 2 to 4 decoder. Why we are using not gate with bubble? Why not without bubble? Yes, this was the same question which I was about to ask. The simple thing is, yeah, one more thing. If we see here, we need to activate the enable of this this decoder as well. So this enable should be connected to the grounded. then it will be activated, otherwise it will not be activated. But the problem is, now let us see here, to enable all the decoders, we require the inverters so that I can get active low signal over here, because here I will get 1, so that should activate the first decoder. If I'm getting even is equal to 1, then it should activate the second one. So now the problem is, what we are doing here, we are complementing with the help of inverter, and we are using one bubbled decoder or the active load decoder. So to remove this thing, what we can do, what is the alternative? Jayant correctly said, we can utilize the active high decoder circuit. Instead of using one inverter over here and one bubble over here, simply use active high decoder. Okay, and that will solve your purpose. You don't need the additional inverters to activate respective decoder circuits. Okay, so definitely you can use the active high one.